Good afternoon to you all. Okay, is my voice audible? Okay, so yesterday I have introduced you the new chapter that is motion in a straight line. Okay, fine. Motion is a straight line. Okay, now I think students are joining, so just I can wait for 2 or 3 minutes. My voice is audible to you all. Okay, my voice is cracking now. Is my voice audible to you all? Okay, okay. So yesterday what I have explained to you. This is a new chapter as per NCERT. The name of the chapter is motion in a straight line. Okay. So from name itself we can understand motion in a straight line. Okay. Now what is motion first of all? So I think yesterday I have explained to you what was motion. Motion is the change in motion is the motion is the change in position of the object. Change in position of a particle with respect to time. So with respect to time, if the particle position is been changing, then it is known as motion. Okay. Now the study of motion in a straight line. The study of motion in a straight line is rectilinear motion. Okay. It's known as rectilinear motion. The study of motion in straight line is known as rectilinear motion. Okay, it is a name. Rectilinear means if the particle is moving in a straight line, then we say it is a rectilinear motion. Now this straight line, this motion can be either vertical, this motion can be either vertical or horizontal, or it can be inclined also. Okay, the motion can be either vertical or horizontal or inclined. So the straight line motion can be horizontal. The motion can be horizontal or vertical, or it can incline also. It can be inclined. Okay, inclined in a plane. Inclined in a plane. Okay, so the motion can be horizontal, vertical, or it can be inclined in a plane. Okay, yesterday we have studied all this point. Is my voice lagging behind? Is my voice lagging behind? Okay, I think now it is fine. Okay, okay. So I will slow myself. Fine. So I told you that this straight line motion can be either vertical, it can be horizontal, or it can be inclined also. It can be inclined, horizontal and vertical. Now I told you about. Okay, now okay, now basically whenever we are studying about uh, motion of a particle, okay, whenever we are studying about motion of the particle, we will study about mechanics. Okay, so in engineering, we will study about mechanics. Okay, what is mechanics first of all? Mechanics is basically the study of machine. The study of machine is mechanics. Study of machine is called mechanics. Okay, fine. Study of machine is known as mechanics. Now within mechanics, we have two parts. Okay, one is kinematics, one is kinematics, other one is dynamic. Okay, okay. So the mechanics basically have two parts. One is kinematics, other is dynamics. Now what is kinematics? Kinematics is basically the study of the effect. The study of effect is known as kinematics. Okay, like I will give you the example of kinematics. Like a particle is accelerating. Okay, a particle is moving in a straight line and it is accelerating. Now, in this kinematics, we want to go inside the particle. That what is who is responsible for acceleration? Why the body is accelerating? Why the body is having constant velocity? We are not going into the detail. Means we are not going to the cause of the acceleration or the cause of the velocity. We are not going inside the cause of the velocity. Fine. So basically, kinematics means it is just the study of the effect. Means a particle is there. If the particle is moving with a constant velocity, it is moving. We are not going in a detail that why it is moving with a constant velocity and who is responsible for moving with a constant velocity. Basically, if you see your car, a car is a machine. Okay, in a machine, you're accelerating. Okay, you have the accelerator, you have the gears, you have the engines, everything is there. Now we know that engine is the one which is providing us the force to accelerate your vehicle. Okay, fine. So if you take only kinematics part, we are only concerned with the acceleration of the car. The car is moving with constant velocity like this only. We are only concerned with the acceleration, velocity. Fine. Dynamic means dynamic means we will study about the cause and the effect. The cause plus effect. Okay. Now what is cause? The cause and the effect. Fine. Cause means why the car is accelerating. Which force is responsible for accelerating the car? Okay, so that is dynamic part. Okay, so dynamic will deal with what? It will deal with the cause and the effect. Cause means why, who is accelerating this car? Okay, which force is responsible for that? That will come under dynamics. Kinematics means simply we have to study about the effect of the force, like effect, like the particle is accelerating. That is the effect. Okay. These are the two parts of kinematics and dynamics. Okay. Yes. Dynamic means cause is the reason why it is accelerating because of the force. Okay. That will come under dynamic part. Kinematic part we only study about the effect, that is acceleration. Okay. So in our chapter we will study about kinematics in one dimension. Kinematics in one dimension. Now, yesterday I was explaining about the dimension. One dimension means either the particle will be moving in x-axis or it would be moving in y-axis or z-axis. Okay, fine. So kinematics one dimension means The particle can either have motion in x-axis, it can have the motion in y-axis, or it can have a motion in z-axis. Okay. Then we'll study about kinematics 1D. So first part of the chapter, that is motion in a straight line, deals with kinematic 1 dimension. 1D. Okay. So from here we are starting our chapter. So basically our chapter is kinematics 1D. Okay. Kinematics, kinematics 1D. Fine. Now in kinematics 1D, first sub topic is position, position, path length, and displacement. And correct. So kinematic 1D is basically the position, path length, and displacement. This is the topic. Okay. Now see kinematics. Kinematics simply says that like a particle is accelerating. So we are only concerned with acceleration of the particle. We are not going into detail that why the particle is accelerating. Okay. So the study of only effect is known as kinematics. Means we are only concerned that a particle is accelerating. That's it. We are not going into detail that why the particle is accelerating, who is responsible for that. Okay. Dynamics means we have to go in detail that which force is responsible for acceleration of the particle, which force is responsible for velocity of the particle, like this. That will come under dynamics. Okay. So the first part of the chapter, that is motion in a straight line, will deal with the first part of the chapter deals with kinematics 1D. Can you all tell me my voice is clear or not? First of all, don't call me. Okay. I am taking the class. Why are you calling me? And if my voice is not clear, you can tell me now. If my voice is not clear, you can tell me. I don't know why it is lagging. My net connection is just wait. Now my voice is clear. Wait. Just now my voice is clear or not? Okay. I means fan was working, so that is why. Okay. Now my voice is clear. Fine. Okay. So fine. So in the kinematics 1D, we'll study about position, path length, and displacement. So position, path length, and displacement. Okay. So first of all, what is position? Now we have studied about motion. What is motion of the body? The motion is the change in position of the object. Motion is change in position of particle with respect to time. So the change in position of particle with respect to time is motion. Now, in order to specify the position, means in order to tell what is position, in order to specify, specify position, we need a coordinate system. We need we need a reference point. We need a reference point. We need a reference point and the set of axes and the set of axes. Okay. So in order to specify the position, we need to have, in order to specify the position, we have to have a reference point and the set of axes. Now axis, I hope you understand what is axis here. Okay. Now if you have ever seen the graph, you must have seen that the graph will have the two axes like this. See, okay, fine. The graph will have the two axes. This will be your x-axis. This is your minus x, y, and minus y. So basically, to specify any position of the particle, we need to have the set of axes. So these are the set of axes: x-axis, x minus x, y minus y. Okay, and one more axis there, z-axis. Now this z-axis is perpendicular to both x and y. The z-axis is perpendicular to both x and y. Now, yesterday only I told you how to get the z-axis. Like if you have your laptop or your mobile, just what you have to do, just you have to place a pencil perpendicular to the, or you have to place the pencil at this point, the point where x and y are meeting. The point where x and y are meeting is known as origin. So this point is the origin. Fine. So at the origin, what we have to do, you have to just place the pencil at the origin. Okay. Now this pencil will represent the z-axis. Okay. So z-axis is basically perpendicular to, the z-axis perpendicular to both x-axis and y-axis. Okay. So it is perpendicular to both x and y. Okay. So basically z-axis will help us to get to three-dimension object. Okay. Z-axis to help us to give the three dimension. Okay. So first of all, for specifying the position, we need to have the axis. So you can see that we have drawn the axis, x-axis, y-axis. Okay. Now we need to have the reference point. Now what is reference point? The point of intersection of both the axes is known as reference point. Now if you see, the reference point is the point where both the axes are meeting. So this is the point, this is the reference point, which is also known as origin. So the reference point is origin here. Okay, the reference point is origin. So to specify the position, we need to have the set of axes, that is x-axis, y-axis. Then we have to have the reference point. Reference point means the point where both the axes are meeting. Okay. In this case, the reference point will be origin. Now, now, now let us suppose that some particle is at this point. Okay. So this represents some particle A. Now, how will you specify the position of the particle? The position of the particle will be specified with respect to the origin. Okay. Now, this point A will have some coordinate also, like x, comma y. So, if I can define x, comma y, okay, then I can define the position of the particle. Okay. If I can get the value of x, comma y, then I can specify the position of the point A. So, if someone asks you, what is the position of A? You will tell that the position of A is x comma y. Means it has x-axis, it has x coordinate x and y. That is the position. Now you tell me this position is what? This position is with respect to this reference point, because we have taken this as origin. So with respect to this origin, the position of the particle is x comma y. Okay. I hope you understand this. Are you getting this or not? Okay, fine. Okay, so I have told you that what is a reference point, what is the position of the particle. To find the position, first we have the x-axis and y-axis. This is your x, this is your y. Then we have defined that the point where both are meeting is reference point. This is your reference point, reference point, or this is the origin, we can say this is origin only. Okay, now if some particle is located at point A, now the location of the particle, the coordinate would be x comma y. So we can say that this particle is located at a point, at a coordinate of x comma y with respect to this origin. Okay, fine. Now I think you understand this. Now you tell me one thing. Now this is the position of the particle. Now in this system, if I put a clock, okay, if I put a clock like this, fine, we have a clock. Okay, now why we are placing the clock here? The we are placing the clock because we have to measure the time. Okay, so if I place a clock in this arrangement or in this system, and after some time the particle A moves from A to B. Now when it moves from A to B, its position will change from x comma y to x dash comma y dash. Okay, fine. Now the particle position changes from A to B. Initially it was x comma y, now it is x dash comma y dash. Now with the help of the clock, can we measure the time taken by the particle to reach from A to B? Okay, so if we can know the time, and if we can know that the position of the particle is changing, then we can say that the particle is in motion. Okay, so motion is basically the change in position of the particle with respect to okay. Now we know the location of the particle x comma y, point A. We also know for B, that is x dash comma y dash. We can calculate the time with the help of the clock. Okay, then we can find the motion of the particle. Okay, understand? So we can write here as, you can write one more point that to measure the time, to measure time, we position a clock in the system, the clock in system. Okay, the the coordinate the coordinate system, the coordinate system, the coordinate system along with the clock, along with the clock is called frame of reference. Frame of reference. Correct. So I think you understand what is frame of reference. The coordinate system. Now coordinate system consists of what? The set of axes, that is x comma x axis, y axis, z axis. Okay. Then we have the reference point. Now the reference point here is origin. Okay. So this constitute the coordinate system. So coordinate system is consists of the set of axes, that is x comma y comma z axis. Then we have the origin, which is the reference point. Okay, and then if I place the clock in that system, if I place the clock in the coordinate system, what we are getting? We are getting the frame of reference. We are getting the frame of reference. Fine. Okay. Did you understand what is frame of reference? Okay. Fine. Did you understand this or not? What is frame of reference? The frame of reference means, see again I will explain you. Just understand properly. I think you understand coordinate system or not. Why it is confusing? See. See. Okay. Now The frame of reference. See, what is frame of reference? Okay, what I told you. See, I will tell you. This time you have to understand properly. Okay. First thing is that in order to specify the position, we need to have reference point. Now reference point and set of axis. Now what is axis? I think if you have studied mathematics, you must know there are set of axis, that is x-axis, y-axis, and z-axis. Okay, we have three set of axis, x, y, and z. Okay, now to specify any position of the particle, we need to have the set of axis. We need to have the set of axis, that is x-axis, y-axis. Then these axes will meet at a point that is known as reference point. Okay. Now reference point is generally origin. So origin is the reference point where the set of axes are meeting. Okay. Fine. So this set of axes along with the reference point is known as coordinate system. Okay. So the reference point with set of axes is known as coordinate system. Okay. So this whole term is known as coordinate system. Okay. So to specify the location of the particle or the position of the particle, we need to have the coordinate system. Okay. Now in this coordinate system, if the position of the particle changes from A to B, okay, the position of particle changing from A to B. Okay. Now if we can measure the time taken, okay, to measure the time we need to have the clock. Okay. So if we can measure the time taken by the particle to move from A to B, okay, then we can find the motion of the particle, because the motion of the particle is the change in position of the particle, okay, with respect to time. So if we have the clock and the particle position changes from A to B, we can measure what? We can measure the motion of the particle. Now Now look at this statement. The coordinate system along with the clock means the coordinate system is what? The set of axis and reference point along with the clock is known as frame of reference. This whole arrangement is known as the frame of reference. The frame of reference will have what all things? First of all, it will have axis, that is x axis, y axis. It will have reference point. Reference point is that point where the axes are meeting. And the third thing is clock. If we have all the three things, we can say that it is known as frame of reference. Okay. So I hope you understood this. Okay. Okay. Next is the parameters which affect the frame of reference. Okay. Next is the parameters. The parameters. The parameter which affects frame of reference. Frame of reference. Or we can say what are the parameters which are involved in frame of reference. Okay. The parameters involved in frame of reference. Okay. The first parameter is time. Okay. First parameter is time. Okay. Yes, the whole thing is known as a frame of reference. Okay. Fine. Okay. The first parameter in frame of reference is time. Now, what is time? I think I told you what is time. Time is the fundamental quantity. Okay. Now, the time is the fundamental physical quantity. The fundamental physical quantity is time. Okay. Fine. And it is the most significant factor. It is most significant parameter. Okay. Fine. Now one more most important point of time is that the time will not change. The time will not change even if we change the frame of reference. The time will not change even if we change the frame of reference. frame of reference. Okay. Now time will not change even if you change the frame of reference. That is the most important point of time. Okay. The time will remain same. Okay. Now I give you one example here. Okay. Just understand that example properly. You are traveling inside the car. You are traveling inside the car. Okay. You are traveling inside the car. Okay. You are inside
हम बयाना नहीं ले रहे काम को अपना खुद करवाना पड़ेगा
you are traveling inside the car. Okay. Fine. It is moving with some velocity. Alright. It is moving with some velocity, say 2 meters per second. Okay. We have a tree like this, and a person is standing here. Okay. On the ground. Fine. Now see, basically we have two different frame of reference. One is the frame of reference which is inside the car. Other is the frame of reference which is on the ground. Okay. Now the time taken by the car to cross this tree would be same for the car as well as the person who is standing on the ground. The time taken to cross the tree by the car, the time taken by the car to cross the tree would be same as the would be same for the person who's standing on the ground. Okay. So from here we have to understand one thing, that the time will not change even if we change the frame of reference. Okay. So in this example we have two different frame of reference. One frame of reference is when the person is inside the car. So car is a frame. Car is a frame. It is a moving frame. Okay. A person on the ground is a stationary frame. Means the frame is not moving. Frame is stationary here. Here the frame is moving. Okay. So we have two different frames. Okay. One frame which is the car, other frame which is the ground. Now the time taken by the car to cross the tree would be same for the time taken by the time calculated by the person to cross the tree for this person. Okay. So even if we change the frame of reference, the time will not change. That is the most important point of the time. Okay. Fine. Okay. Fine. Okay. No. Even if your speed changes, see, time taken, just listen to my words. Okay. The time taken to cross the tree for the person who's inside the car and for the person who's outside the car, like the person who's on the ground, will be same. Will be will be same. Okay. That is what I'm telling you. Okay. Even if you change the speed also, the time taken to cross the tree would be same for both the person. One for the person who is inside the car and for the person who is outside the car. Okay. That is why time does not depend upon the frame. No. You will read fast. That is, I am saying that the time taken for the person to cross the tree for the person who's inside the car would be same as the time taken to cross the tree by the car for the person who's outside the car. Time will remain same now. It is not about how fast or how slow the car is going. The time taken to cross the tree will be same for both the person. The person who is on the ground and who's the person who is inside the car. Okay. Just understand my words which I am telling you. The time taken to cross the tree would be same for both the person. You keep the speed constant, you increase the speed, whatever you do, but the time to cross the tree for the person would be same would be same for the person inside the frame and for the person outside the frame. Okay, fine. You have, see, I can explain you, but you have to use your own brain. Okay, you have to imagine. Without imagine, you cannot do that anything. Okay, I'm again explain. I am telling you again. I'm explaining you properly only. You have to use your brain. Okay, without imagination, you cannot do anything. Okay, next is next parameter is position. So I think I explained to you about position. See this point of time, I will explain you properly when I will change. I will teach you frame of reference again. Okay. So for now, you just understand this term that time will not depend upon frame of reference. Okay. You will have understanding there also. I'm just giving you the introduction part here. Fine. Next is the position. Now position, I told you that to specify the position, we need to have x-axis, y-axis. Okay. Say point A. This is what the frame. This is reference point. Okay. So to specify the position, we need to have x-axis, y-axis, z-axis, and the reference point. Okay. Now one thing about position is that this position is with respect to this origin which we have specified here. Now if I change the reference point, will the position of the particle changes? If I change the reference point, will the position of particle changes? Instead of taking this as reference point, can I take here as reference point? Here I can draw x-axis or y-axis. Here we can draw x and y-axis like this. Wait, instead of this reference point, can I change the reference point? Like now I have taken this as x-axis, minus x, y, and minus y. Okay, now this is my reference point. This is my reference point. Now, will the position changes if I change the reference point? Yes or no? No, the position will not change if reference point will change. Only distance will change. Okay. Actually, the position will also change. If you change the reference point, okay, if you change the reference point, the position of the particle will also change. How? I'll explain you how. See, if you take this as reference point, this as x-axis, y-axis, and reference point, the the position would be what? X comma y with respect to this reference point. Okay. Now, if you take this as reference point, then the position of A will change. Now, with respect to this reference point, the value of A can be x dash y dash. Means the position of the particle changes if I change the reference point. You can see the figure itself. Here A is very close to reference point, but here A is far away from reference point. So location will change, x dash, y dash. Okay. So if you change the reference point, the position of the particle will changes. Okay. So position of the particle depends upon the reference point. Okay. Fine. So you can write here as the position of the particle the position of a particle depends upon reference point. Reference point. Okay. So if you change the reference point, the position will also change. Okay. The position of the particle depends on reference point, but the real location, the real location will remain unchanged. The real location will remain unchanged. Will remain unchanged. Okay. Now see, See, if you look at my, if you look at, see, I'll explain you again. You will have one better understanding of position here. See, if you look at my PowerPoint presentation, you can assume this as x-axis. Okay, this can be assumed as x-axis. Okay, this can be assumed as y-axis. Okay, this is your reference point. Reference point. No, okay. If I draw a dot here, anywhere in the PowerPoint like this, I have drawn a dot here. See, this is the point A. Now, with respect to this reference point, the point A will have some coordinates, say x comma y. Okay. Now, if I change this reference point, instead of this reference point, can I take this as reference point? This end. This will be your y-axis. This is your minus x. Okay. Now, with respect to this reference point, you will see that the position of the particle changes. Okay. The position will change. If I take this as reference point, again the position will change. If I take anywhere else, if I take here, this as a reference point, like this is the reference point. This is y, x, then also position will change. So which means the position depends upon the reference point. The position depends upon the reference point. Fine. But the real location will not change. The particle at A will remain at this position. The particle, this will remain here only. This real location will not change, but the position will change. Means if I change the reference point, I can change the position of the particle, but real location will never change. Okay. No, no, no. See, that is why I'm telling you. Whenever we are locating some particle, we have to specify the reference point in the question itself. In question itself, they will tell you the reference point. Okay, then your answer will not be wrong. Okay, so in the question language itself they will tell you the reference point, that this is the reference point. With respect to this point, the location of the particle is here. Okay, so if they have to mention the in the question itself what is the reference point. Okay, fine, but they can ask you the question like this, like this, that if the reference point is changed, will the position of the particle changes? Yes, it will change. The position will change when you change the reference point. Okay, so this type of question can be asked. Fine, I hope you understood this. Okay, but the real location will not change. Real location means this is the real location of the particle, the dot I have made there. I, I am changing this A. I am not changing this A, but I am changing the axis. I have taken this as first axis. This is the first axis we have taken. Then second axis, this one. Then third axis, this one. Then fourth axis, this one. We can take any other axis also. Like this point can be taken as axis. Okay. This is your minus y, minus x reference point. So if you change the axis, the position will change, but the real location will not change. Okay. Yes, the real location will not change, but position will change with respect to reference point. Okay. Answer will also change. Yes, that is correct. Your answer will also change if you change the reference point. So in the question itself, they will give us the reference point. Okay, then your answer will not change in that case. Okay, fine. I hope you understand the reference point. What is the position of the particle? Okay. Time will not change with reference point. Okay, like just I give you one example here. Initial position of the particle was A. Now it changes to B. Okay, fine. Now the time taken to change from A to B will remain same if you change the frame of reference also. Means whether the frame of reference is here, whether the frame of reference is here, anywhere, the time taken to change the position of the particle from A to B will remain same. Whatever the reference is there, whatever frame is there, the time to change from A to B will remain same. Okay. Now I think you understand why the time does not depend upon frame of reference. You can think logically also that let us suppose if I take this as frame of reference, the position was x comma y. Now it changes to x dash comma y dash. Okay. Now it has taken say 2 seconds to change from A to B. Fine. Now if you take this reference point also, then also time taken will be same. A to B will be 2 seconds. If you take this as reference point, then also it would be 2 seconds. If you take this also, that it would be 2 seconds. But if you change the reference point, the position will change. But the time taken to change the position will remain same. But the time taken to move from A to B will remain same, but the position will change if you change the reference frame. Okay, fine. I hope to understand this. Both the points you have understood why the time does not depend upon frame, what is frame, and what is reference point. Fine. Okay. Now next is display distance and the path length. Okay. Distance oblique path length. What is distance or what is path length? Okay. Distance is the actual length of the path, covered by the particle. Covered by the particle. The actual length of path covered by the particle is distance. Okay. Now distance is scalar quantity. Now I have not explained you about scalar and vector. Okay, that I will tell you now. Is a scalar quantity and it can never be negative. Never be negative. Okay, so distance or a path length is the actual length covered by the particle. Like if I give you one example here, a particle was at point A. Okay, it reaches B. Now to reach B, it can take different path. Like this can be one path, like this. This can be another path, or this can be another path. You can see that to reach from A to B, the particle may take different paths. Okay, I can say that this is path 1, this is path 2, this is path 3. Okay, now what is distance? Distance is the actual length of the path covered by the object. See, all the things which I am telling you is under motion in straight line. Okay, fine. So I am not starting any new topic. It is just the continuation of the previous topic. Okay, so distance or the path length is the actual length of the path covered by the particle. Now just think on this point. When I travel from A to B, I have taken path 1, so it must have some distance covered by the particle or the path length covered by the particle. When I move from A to B via path 2, then the how much distance I have covered, how much path length I have covered. Similarly, from A to B also some distance is there. Okay, so path length is basically the actual length of the path covered by the particle. Actual length of the path covered by the particle is known as path length. Okay, and it is a scalar quantity. Now, what is scalar quantity? It will come under parameter only. Fine. Under parameter only it is coming. Okay. Yes. Now distance is a scalar quantity. Scalar quantity means it has only magnitude. It has only magnitude. Okay. Scalar quantity means it has only magnitude. So distance is a scalar quantity and it can never be negative. Distance is the total path length covered by the object. So if you take the three parts, 1, 2 and 3, how much length it has covered, how much length it has covered is will come under distance. Okay, fine. Now next is displacement. See, there is no difference between path length or distance. Both are the same thing only. Path length and distance are the same thing only. Okay, that is why it is written as distance oblique path length. Both are the same only. Okay, now fourth parameter is displacement. What is displacement? Displacement is the shortest distance between initial and the final position. Initial and the final position. The shortest distance between initial and final position of the particle is called displacement. Is called displacement. Okay, that is known as displacement. Fine. Okay, fine. So displacement is the shortest distance between the initial and the final position of the particle. Okay, now I'll give you one example here. Like we have the like you are at home. Okay, you have to go school. Fine. Definitely, no one want to go from home to school. Okay, so what you will do? You have different path to go. So while going from home to school, you want to reach the school as late as possible because you don't want to go to school. For that, what you will do? You will take the longest path, or we can say that you started from point A, you reach point B, then you go to school at point C. So this is the path covered by you, that is from A to B, then B to C, from home to school. Fine. Now, when the school get over, you want to reach home as soon as possible. To reach to home as soon as possible, you have to take the shortest path. So you will start from C and you will reach A. So you can see that the distance between A and C is the shortest path. Okay, distance between A and C is the shortest path. Remaining A to B and C is the long path. Okay, you can take another path also like this. Okay, it depends upon you. Okay, so what is displacement, what is distance? Okay, displacement is the shortest distance between the initial and the final position of the object. Is the shortest distance between the initial and final position of the particle is known as displacement. Okay, fine. Okay, the shortest distance between initial and final position. Now, what was the initial position? School is the initial position. C. What is the final position? Home. A. So the shortest distance between home to A, between your school to home is AC path. So AC is the displacement. AC is the displacement. Fine. Now, if I ask you, what is ABC? ABC is the path length. ABC is a path length or distance distance. Even this path, this path, this zigzag path is also a path length. Okay, this is also a path length or distance. Okay, so from a one what we can understand, distance can be displacement can be said like the shortest path length or shortest distance between the initial and final position is known as displacement. So shortest distance between initial and final position is the displacement. Okay, fine. Understand this or not? The shortest distance between initial and final position is known as displacement. Okay, now this displacement is a vector quantity. The displacement is a vector quantity. Now what is vector quantity? Vector quantities are those quantities which has magnitude and direction. Okay, which has magnitude and direction is known as vector quantity. Okay, now okay, now I'll explain you one more point. See, just tell me one point, like this example only, this school and home example only. This was your home, this was your school. Okay, now you tell me one thing, the displacement will be the only one path will be displacement, because only one path will be the shortest path between A and C. So we can see that A and C is the shortest path. If I draw simply a straight line connecting A and C will be your shortest path. If I take any other path, that path will be longer than AC. Okay, if you take any other path except this path, a straight line which is connecting A and C, except this path, any other path you are taking is more than AC. Okay, like this. If you take this path like this, or you take this path, any path you take, it would be longer than AC. Fine. Now, displacement is the shortest path. Now, to specify displacement, I need to have the magnitude. Now, magnitude can be what? We can assume like that the distance between A and C is 5 kilometers. Okay, so 5 kilometer is the magnitude of the displacement, and in order to reach C I have to travel in this direction. From A to C I have to travel in this direction. So for a displacement I need to have a proper direction, and I need to have the magnitude of the path length. So if I have both the thing, then only I can say AC is the displacement of the particle. So displacement means it should have a direction. So for displacement I need to have the specific direction, that if I travel in this direction I will reach the school in the shortest possible path. Okay, so to define displacement I need to have the direction as well as the magnitude. The magnitude here is 5 kilometer, direction is along this direction. The arrow direction shows the direction of the path. Okay, that is why displacement is vector quantity. Okay, yes, displacement is the vector quantity. Fine. I hope you understand vector quantity. Okay. Okay. Fine. Now, we can define displacement in another way. That displacement is the change in position of the particle. Displacement is change in position of the particle. Position of particle is displacement. Okay. The displacement is the change in position of the particle. Okay. So when I move from A to C, the position of the particle is changing. Means initially I was at A, I have changed my position to C. So displacement is basically the change in position of the particle from A to C. So we can also define displacement as the change in position of the particle. Okay. Magnitude, wherever I'm telling you magnitude is the distance between A and C. Okay. The distance is magnitude. So for displacement, I need to have the for displacement numerical value. Yes, you are correct. Either you take numerical value or magnitude. Okay, so to define displacement I need to specify the magnitude or numerical value or distance between A and C, or the shortest distance between A and C is the magnitude, and direction should also be known to us. So if I know these two quantities, I can define displacement. Yes, yes, displacement can be distance also. The shortest distance is displacement. The shortest distance is displacement. Okay. So AC is displaced distance also, but the shortest distance is known as displacement. Okay, fine. Scalar quantity, it has only magnitude, like this distance. See, if I have some measuring tape, I can measure the distance between A and B along this path. Okay, so the distance measured with the help of measuring tape will be the magnitude of the distance. Okay, will be the magnitude of the distance. So for distance, we only have to need to know the magnitude. Okay, the main difference between scalar and vector is that scalar scalar only has magnitude. Okay, vector will have magnitude as well as direction. Okay, vector will have direction as well as magnitude. Scalar will have magnitude only. Okay, fine. So you can see all the slides. Okay, that was the first slide we have discussed today. Second slide. See, and the three path I have drawn, I am telling you the different path you can take to reach A to B. Okay, so I can take different path. Okay, the shortest path will be the displacement. The shortest path will be the displacement. Okay, you can take different path to reach from A to B, but the shortest path will be the displacement. Okay, see frame of reference. See frame of reference is basically what? Frame of reference is the axis along with the reference point is the frame of reference. Okay, frame of reference. Reference point is that point where the axes are meeting. That is origin. Origin means the reference point, and frame of reference means when you place when we have a set of axes with reference point with clock, then it is the frame of reference. Like car is a frame of reference. It is moving frame. Car is moving frame. Lift is a moving frame. Okay, now you can see the car will have a coordinate axis also. It will have some reference point also. That is the that is moving frame. That is frame which is moving. Okay, now you take earth. Earth is the stationary frame. Okay, that is earth is also a frame. Fine. Magnitude, I'm telling you, magnitude distance magnitude means like you have three parts, 1, 2, and 3. You take a measuring tape and measure the distance between A and C by using path 1. The reading which you will get is the magnitude of the distance. Okay, fine. I hope you understood. Yes, a coordinate system along with no coordinate system along with the time. With time is known as frame of reference. Okay, so thank you all. Yes, it is a lesson. It is a motion in straight line. Okay. No, today dot clarification class is not there for you for me.